Hello students, welcome back to part 3 of the video. Here we are going to discuss a very important topic which is adsorption isotherm. So let us begin. First of all, why does adsorption occur? So the reason behind it is, let us understand by this diagram. In this diagram we can see we have taken a liquid over here. Now the particle which is in bulk of any substance, liquid, solid, gas, whatever, the particle which is in bulk is experiencing equal forces from all the sides. Okay, because it is inside. So equal, same type of molecules are there surrounding that particular particle. Okay, so it will experience balanced forces from all the sides. Whereas the particle which is on the surface, let us take this particle, the particle which is on the surface is experiencing unbalanced force. You can see below it liquid particles are there, above it air is there. So it will experience an unbalanced force, okay, because of which this particular adsorption process occurs. So in brief, we can say due to unbalanced or also known as residual forces which are attractive in nature, the adsorption process will take place. Okay, now you can see over here, if any gas will come over here, if any gas will be present, then due to this unbalanced residual attractive force, those gas particles will get attracted and retained on the surface of this particular liquid. Okay, fine. Now let us talk about adsorption of gases on liquids. Basically we will talk about adsorption of gases only in detail, okay, and adsorbent taken will be solids only most of the cases, fine, because solids are better adsorbents. Okay, so almost all gases get adsorbed on solids, fine, but the extent of adsorption is different for different type of gases, and we are talking about physisorption, because in chemisorption we have already studied that chemical bonds have to be formed, no attractive forces or van der Waals forces are there. Okay, so now extent of adsorption upon solids, it depends upon certain factors which are being written over here. We'll discuss those factors one by one in detail. Okay, the first factor is nature of gas. Now when we are talking about nature of gas, it means that easily liquefiable gases can get adsorbed more easily. Okay, now what does liquefaction means? Fine, or on what factors liquefaction depends. So remember, ease of liquefaction depends upon critical temperature. Okay, critical temperature. Let me define you critical temperature first. It is the temperature above which a gas cannot be liquefied. Okay, temperature above which a gas cannot be liquefied. Fine. So just remember one thing, means the ease of liquefaction, it depends upon critical temperature. Always remember, higher the critical temperature, more easily the gas will be liquefiable. Okay, so greater the critical temperature, TC here means critical temperature, more liquefiable the gas, okay, and higher will be its adsorption. Is it clear? First point, how does the nature of gas affects? Nature of gas directly depends upon the ease of liquefaction. More easily the gas can be liquefied, more will be its extent of adsorption. Okay. Now let us move to the second factor, that is nature of adsorbent. Now nature of adsorbent means the property, the characteristic of an adsorbent due to which it can adsorb easily. Okay, we will not go much into detail about it. Just you should know that, like for example, charcoal is there. It is a good adsorbent. It has the capacity to absorb all sorts of poisonous gases, etc. Okay, so over here, nature of adsorbent, that is, it should have the ability to absorb properly. That is important. Third one is specific area of adsorbent. Specific area, in simple terms, you should know, or you can say surface area. Okay, surface area available for absorption per gram of adsorbent. Okay, that is known as the specific area. Fine. So simple, surface, higher the surface area, more will be the adsorption. Okay. Then effect of temperature. Now effect of temperature is also very important. Why? How can we say effect of temperature? See, we know adsorption is an exothermic process. Okay, I'll write here. It is an exothermic process. Fine. So, for example, gas plus solid. Here gas is what? Adsorbate, and solid is adsorbent. Okay. Here, in this case, adsorption occurs. Okay. This is an exothermic process. Fine. So, heat is liberated. So, what we get? Gas adsorbed on solid. Okay. Plus heat, because it is an exothermic process. And the opposite of it, which is desorption. In case of desorption, this is an endothermic process. Okay, it is, the opposite is endothermic process, desorption. So remember one point, effect of temperature, what it will be? More you will increase the temperature, that higher the temperature, lesser will be the adsorption. Okay. If you increase the temperature, adsorption will decrease. What will occur? Desorption, because desorption is an endothermic process. It requires heat. So, if you are giving heat, what will happen? Desorption, not absorption. Okay. Now, the last factor, which is effect of pressure. Now, it's quite simple. Gases means pressure affects gases tremendously, and so if you increase the pressure, obviously adsorption will increase. Fine. So these are the various factors which affect extent of adsorption over any adsorbent, basically solid. Now let us see adsorption isotherms. What are isotherms? Iso means constant, therm means temperature. So when at constant temperature the certain graphs are being plotted for adsorption, that are known as adsorption isotherm. Let us define that first. It is the relation between amount of substance adsorbed by adsorbent and the equilibrium gas pressure at constant temperature. Okay, this is temperature over here. Fine. So that is adsorption isotherm. Now the extent of adsorption was given by a relation x by m, where x is the mass of adsorbate and m is mass of adsorbent. Okay, adsorbent basically what we are taking here? Gas, and adsorbent will be solid. Okay, now at a certain pressure, the extent of adsorption becomes exactly equal to extent of desorption. We say that condition equilibrium. Okay, and that pressure is known as equilibrium pressure or saturation pressure. Okay, PS. We call that PS, saturation pressure, when the extent of adsorption becomes equal to the extent of desorption. Now many scientists tried to explain these adsorption isotherm or gave adsorption isotherm. One of them was Freundlich, and let us see his adsorption isotherm. Langmuir was there, but we have to study this in our course. Okay, so Freundlich adsorption isotherm, he gave a relation which is x by m, we know is directly proportional to P, that is pressure. X by m is extent of adsorption. This is extent of adsorption. Okay. Therefore, x by m is equals to Kp. We can write K is the constant. Now he plotted the graph for extent of adsorption versus pressure. On x-axis pressure and y-axis x by m. So the graph which was obtained was like this. At low pressure, a straight line was observed. Okay, that is x by m is directly proportional to pressure. Then at intermediate pressure a curve like this was observed, okay, and at high pressure a constant line was being observed. Fine, a constant line was observed. Okay, now it was seen that this at low pressure, it was seen that x by m is equals to kp directly till here, isn't it? Because you can see a directly proportional line, so extent of adsorption is directly proportional to pressure. Okay, at high pressure when you are observing a constant line till here to till here, now we can it was written x by m is equals to kp to the power of 0. Here it is p to the power of 1, so directly proportional. Here p to the power of 0, we know it is what? 1. So it will be x by m is independent of pressure. As much pressure you increase, there will be no change in the extent of adsorption. Okay. And in the intermediate you were getting x by m is equals to kp to the power of 1 by n. At the intermediate pressure, the relation was written like this. X by m is equals to kp to the power of 1 by m. Okay. Now, we can write over here, see, at low pressure, x by m is directly proportional to, or I can write is equals to kp to the power of 1. Okay. At, that is dependent, directly proportional. At high pressure, x by m is equals to kp to the power of 0, that is independent of pressure. Independent. Extent of adsorption is independent of pressure. Okay, pressure. And at intermediate pressure it was seen x by m is equals to kp to the power of 1 by n. Okay, so that means that 1 by n, the value of 1 by n, value of 1 by n should be between 0 to 1, isn't it? Because here it is p to the power of 1. So in this case what? At low pressure we can say 1 by n is equals to what? 1. At high pressure 1 by n is equals to 0. Okay. And at intermediate the value of 1 by n should be 0 to 1. That is some fractional value, 0.5, 0.25, 0.75, so on. Okay. And or you can also say that at low pressure n should be what? 1. Then only, that is 1 by 1 is equals to 1, isn't it? The value of n I am substituting. At high pressure n is infinity. So 1 by infinity is equals to 0. Okay. And at intermediate n should be what? Between 1 to infinity. Okay, understand this point. Fine. So these should be the values according to which the relation was being given. Okay, now we can take the this one, that is log of this particular relation. The relation was x by m is equals to kp to the power of 1 by n. Okay, this was the relation. So let us take the log. Take log of this value, take log. So it will become what? Log x by m is equals to log k. This equation will become plus 1 by n log p. Okay. Now, this is equivalent to the equation of a straight line, that is y is equals to mx plus c. Fine. Now, if I am plotting a graph for this particular equation, see I am plotting the graph over here. We'll plot for log x by m and it will be pressure now, so it will be log p. Okay, so this is log k is what? Intercept c, and m, that is slope, is what? 1 by n. So the graph will start from here. It will be like this, or let me show like this. This point will be what? Here it will be log k, that is the intercept. Fine. and this is the slope, which is 1 by n. Is it clear to all? So this is the Freundlich adsorption isotherm, which gives you the extent of adsorption, which gives the relation between the extent of adsorption to that of pressure. Now stay tuned for our next video, which will be on the next topic, which is catalysis, and go through this video very properly, because in the next video there will be some very important board questions related to this video.